Hello dear students, welcome to mathematics class. In this class, let us discuss some more examples on Riemann integral. So that the first one is, show that f of x equal to x square is Riemann integrable on the closed interval 1 to 4 and integration over 1 to 4 x square dx is equal to 21. So here the given function is f of x equal to x square and the interval is 1 to 4 and the common value of the Riemann integral is 21. Let us solve this one. Let p is equal to first point 1 as it is, then 1 plus 3 by n, that is 1 plus b minus a divided by n plus 1 plus 2 into 3 by n, because 2 into b minus a divided by n, and so on 1 plus r minus 1 into 3 by n plus 1 plus r by n into 3 and so on 1 plus 3 times n by n, which is equal to 4. So here this one is 1, then 1 plus 3 by n as it is. The third point becomes 1 plus here 2 into 3, that is 6 by n, and so on 1 plus 3 times r minus 1 by n and 1 plus 3 times r by n and so on, that is equal to 1 plus 3, which is equal to 4, because n and n will get cancelled, remaining 1 plus 3. So this is the partition for the closed interval 1 4. For any sub interval IR, here the limits of the rth sub interval are 1 plus 3 times r minus 1 by n, 1 plus 3 times r by n, where r takes the values from 1 to n. Now to find the LPF and UPF, we need the upper and lower sums, infimum and supremum. For that, small mr is equal to, here the given function is f of x equal to x square, means it is increasing. As the value of x goes on increasing, the total function will also increase. So therefore, to find the infimum, we need to substitute the lower limit of the interval into the given function. So therefore, the given function is x square, here 1 plus 3 by n into r minus 1 whole square, because x square is there. Now apply the identity a plus b whole square, that is a square plus b square is 9 by n square into r minus 1 whole square plus 2ab, that is 2 times 3 by n r minus 1. So therefore this one is 1 plus 9 by n square r minus 1 whole square plus 6 by n into r minus 1. So it is the given infimum, that is small mr, 1 plus 9 by n square r minus 1 whole square plus 6 by n r minus 1. Similarly, we can find the supremum, that is capital MR, 1 plus 3 times r by n, because it is the upper limit of the interval IR whole square, since the given function is x square. Here also apply the same identity a plus b whole square, that is a square means 1, then 9 by n square r square plus, because b is 3 by n into r, that is 9 by n square r square, into 2ab, that is 2 into 3 into r by n, that is 6 into r by n. So therefore this is the supremum of the given function f of x in the rth sub interval. So these are the supremum and infimum of the function. Now find length of the subinterval IR, that is delta R. Delta R is upper limit of the interval minus lower limit of the interval, that is 1 plus 3 R by n minus 1 plus 3 R minus 1 by n, it is equal to 3 by n. Here you can easily simplify because plus 1 and minus 1 will get cancelled, then remaining 3 R by n, here 3 into R minus 1 by n, then 3 R by n, here minus 3 R by n will get cancelled, remaining 3 by n, that is the delta R. Now find LPF. Here LPF is given by summation over R is equal to 1 to n and infimum of the interval IR, that is small mr, into length of the interval delta R. It is equal to summation over R is equal to 1 to n. Here small mr, that is infimum is 1 plus 9 by n square R minus 1 whole square plus 6 by n into R minus 1 into here delta R, that is 3 by n. Now we can multiply that 3 by n to these 3 terms separately and also applying the summation separately. Then this becomes summation over R is equal to 1 to n, here 1 into 3 by n, that is 3 by n plus summation over R is equal to 1 to n, then 9 by n square into R minus 1 whole square into 3 by n, here 9 into 3, that is 27 divided by n cube because n square into n into R minus 1 whole square plus summation over R is equal to 1 to n, here 6 by n into R minus 1 into 3 by n, 6 into 3, that is 18 by n square into R minus 1. So therefore this is the simplified form of the previous step, that is the summation over R is equal to 1 to n 3 by n, then summation over R is equal to 1 27 by n cube R minus 1 whole square, and here 18 by n square into R minus 1. Now we can take the terms which are independent of R in the summation. Here this 3 by n is constant, means it is independent of R, into summation over R is equal to 1 to n 1 plus 27 by n cube into summation over R is equal to 1 to n R minus 1 whole square plus summation over R is equal to, here 18 by n square is independent of R, 18 by n square summation over R is equal to 1 to n R minus 1. Now this one is equal to 3 by n into n because we are adding this one n times, so therefore that becomes n plus, here it is 27 by n cube into here. Now we need to put the values for R from 1 to n. Now if you substitute R is equal to 1, that becomes 0 square because it is R minus 1 whole square plus 1 square, 2 square and so on up to n minus 1 whole square plus 18 by n square into, here it becomes 0 plus 1 plus 2 up to n minus 1. So here this 1 square plus 2 square so on up to n minus 1 whole square, that is the sum of squares of first n minus 1 natural numbers and 1 plus 2 plus up to n minus 1, that is the sum of first n natural numbers. So therefore here we can write this sum as by using the formula, that is n into n plus 1 into 2n plus 1 divided by 6, that is the sum of squares of first n natural numbers, and this sum is given by n into n plus 1 by 2, that is the sum of first n natural numbers. Now here LPF is equal to 3 by n into n plus 27 by n cube. So here this is 1 square, 2 square up to n minus 1 whole square plus 18 by n square into 1 plus 2 up to n minus 1. Now, this one is here n get cancelled, it is 3. Now, 27 by n cube into this is the sum of squares of first n natural numbers. So, therefore, this sum becomes n minus 1 into n into 2n minus 1 divided by 6 plus 18 by n square into n minus 1 by 2. So, here you can write the formula, that is n into n plus 1 to n plus 1 divided by 6. So, this is the formula of the sum of squares of first n natural numbers. Here in place of n we have n minus 1, then substitute n minus 1 in this formula, we get n minus 1 into 2n minus 1 divided by 6. This is nothing but n into n plus 1 by 2, sum of first n natural numbers. So, here n in place of n substitute n minus 1. So, then n into n minus 1 by 2. Now, it is equal to 3 plus, so here it is 27 divided by n cube is there. So, n and n will get cancelled, remaining n square, and here n minus 1 into 2n minus 1 divided by 6 plus here also n and n get cancelled, 2 ones are 2 nines are, then it becomes 9 into n minus 1 by n. Now, this one is 3 plus, here you can simplify this 27 and in the denominator we have 6, that is 3 2s are and 3 9s, then it is 9 by 2, and here we have n minus 1 2n minus 1 divided by n square plus 9 into this n minus 1 by n can be written as 1 minus 1 by n, dividing that n in the denominator separately. So, therefore, that becomes 1 minus 1 by n. So, therefore, it is equal to 3 plus 9 by 2 into. Now, this can be written as n minus 1 by n into 2n minus 1 by n, because denominator is n square, that is n into n, plus 9 into 1 minus 1 by n, that it is equal to 3 plus 9 by 2. Here also we can write this one as 1 minus 1 by n and this one as 2 minus 1 by n, dividing the 2n by n, that is 2, then 1 by n, plus 9 into 1 minus 1 by n. So, it is the LPF for the given function. Then similarly we can find UPF. So, here UPF is equal to summation over r is equal to 1 to n capital MR into delta r. So, here small summation over r is equal to 1 to n capital MR. So, capital MR is given by 1 plus 9 by n square into r square plus 6 times r by n into 3 by n, that is the length of rth subinterval delta r. Then here also we can multiply this 3 by n to all the 3 terms separately and also applying the summation separately. Then summation over r is equal to 1 to n, this becomes 3 by n plus, because we are multiplying this 1 by 3 by n. Then summation over r is equal to 1 to n, here 9 into 3, that is 27 divided by n cube into r square, and summation over r is equal to 1 to n, 6 into 3, 18 divided by n square into r. Now, it is 3 by n. If you take this 3 by n out of the summation, then you will remaining with 1, then after adding that 1 n times, this becomes n plus here 27 divided by n cube, remaining summation over r is equal to 1 to n r square plus 18 by n square, and this one is summation over r is equal to 1 to n r. Here n and n get cancelled, this one is 3 plus 27 divided by n cube. So, here we have summation over r is equal to 1 to n r square. Then if you substitute 1, that is 1 square plus 2 square plus 3 square up to n square, means this is also the sum of squares of first n natural numbers, and here it is the formula n into n plus 1 into 2n plus 1 divided by 6. So, therefore, this sum can be written as n into n plus 1 into 2n plus 1 divided by 6 and 18 by n square into, here summation over r is equal to 1 to n of r, that is nothing but the sum of first n natural numbers, and its sum is n into n plus 1 divided by 2. Now, it is equal to 3 plus, here n and n get cancelled, 3 2s are 3 9s, then it is 9 by 2 n plus 1 2 n plus 1 divided by n square plus 2 1s are 2 9s are, then it is 9 into, here also n and n get cancelled, remaining n plus 1 divided by n. So, this is the UPF, and we can simplify further, then it is equal to 3 plus 9 by 2, and this n square can be written as n into n, that is n plus 1 divided by n into 2n plus 1 divided by n plus here 9 into 1 plus 1 by n, dividing this n plus 1 by n separately, that is n by n is 1, then plus 1 by n. So, therefore, this one is the UPF. And again, this step can be written more simply as UPF is equal to 3 plus 9 by 2. So, here this n plus 1 by n is there, we can divide this n plus 1 by n separately, then we can write 1 plus 1 by n plus here into 2n plus 1 divided by n is there, and again if you divide this 2n plus 1 by n separately, that becomes 2 plus 1 by n plus 9 into 1 plus 1 by n. So, therefore, it is the UPF. Hence, we can write LPF is equal to 3 plus 9 by 2 into 1 minus 1 by n, 2 minus 1 by n plus 9 into 1 minus 1 by n, and UPF is 3 plus 9 by 2, 1 plus 1 by n, 2 plus 1 by n plus 9 into 1 plus 1 by n. So, these are the upper and lower Riemann sums. Next, let us find the upper and lower Riemann integrals. First, lower Riemann integral, integration of bar 1 to 4 f of x dx is equal to supremum of LPF such that P is the partition of the closed interval 1 to 4. Now, it is equal to, here while finding the supremum we need to apply the limit as n tends to infinity. Here the LPF is 3 plus 9 by 2, 1 minus 1 by n, 2 minus 1 by n plus 9 into 1 minus 1 by n. Now, after applying the limit as n tends to infinity, this term becomes 0, this is also 0, this also 0, then it is 3 plus 9 by 2. Now, 1 minus 0, that is 1, 2 minus 0 is 2 plus 9 into 1 minus 0, that is 1. So, 2 and 2 get cancelled. Now, it is 3 plus 9 plus 9, that is equal to 21. Then upper Riemann integral 1 to 4 bar f of x dx is infimum of UPF such that P belongs to the partition of the interval 1 to 4. Then it is equal to limit as n tends to infinity. Here UPF is 3 plus 9 by 2 into 1 plus 1 by n, then 2 plus 1 by n plus 9 into 1 plus 1 by n. Now after applying the limit as n tends to infinity, this 1 by n becomes 0, this is 0, this one is also 0, then remaining 3 plus 9 by 2, here it is 1 plus 0, 1, 2 plus 0, 2, then here 9 into 1, that is 1. Then 2 get cancelled, remaining 3 plus 9 plus 9, which is equal to 21. So therefore, here we can see that lower Riemann integral and upper Riemann integral are equal. So therefore, integration over bar 1 to 4 f of x dx is equal to integration over 1 to 4 bar f of x dx is equal to 21, and this 21 is nothing but integration over 1 to 4 f of x dx, means the common value of the Riemann integral, that is equal to integration over 1 to 4 f of x dx, and f belongs to R of 1 to 4, means R is Riemann integrable over the interval 1 to 4 and its common value is equal to 21. So therefore, this is our required proof of the given example.